Hi, so welcome to Managing Big Facades with Rhino Inside. This is the second course in this two-part series on Rhino Inside. So in the first course, we looked at the basics of Rhino Inside and applying it to maybe the earlier stages, such as the concept stage of the design process. In this course, we'll be looking into some of the workflows, techniques, and challenges of managing large and complex facades using Rhino Inside, and especially during maybe the later stages of the design process, let's say schematic design or DD, for example. In this course, we'll be using Rhino 6, Grasshopper, Rhino Inside Revit, and of course Revit itself. Specifically, I'll be using Revit 2019, but as long as you have 2017 and above, Rhino Inside should be compatible. So just to recap, and as I mentioned before, many of the products that you are familiar with here at BIG have been developed and documented using BIM, and specifically for us, that means Revit. So as a BIM specialist helping some of these projects, one of the areas where we spend most of our time developing workflows is to aid in the development and generation of large, complex facades. Whilst Revit comes with certain tools to help this, our unique designs often present more challenges in managing efficient workflows for teams to move from design into documentation. Often when we're dealing with large buildings coupled with kind of more complicated geometry or stepping incremental geometric massings, we have to utilize computational tools in both design and production workflows. And so looking through some of our projects, you can clearly see the utilization of computational tools to help realize them. For example, the Tela Sky Tower in Calgary was developed in Rhino and Grasshopper and documented in Revit. Same for the Vancouver House in Vancouver. You can see, these kind of facades would take a significant amount of time to manually model them. The King Street development in Toronto, a lot of time was spent in developing this kind of pixelated mega panel facade system. East 126 in New York was developed using scripts to explore designs and also place adaptive components in Revit. Again, the 11th Tower in New York, clearly utilizing some computational processes, especially in the Revit side, developing an overall mega panel and placing and updating panel information within it. And the project that we're going to be looking at today, which is called The Creamery, it's a project based in San Francisco. And this is one of the recent projects where we actually tested and implemented Rhino Inside to aid in the development of the facade. And so that's why I wanted to explore this one, as it's a recent project. It's a public project. It's not on the website yet, but it should be up there soon. So the project consists of 4 stepping towers that converge into 2 separate, twin towers, so to speak. And this project really represented many of the challenges we see in our projects, especially in the facade. In these images, you'll see, we started out in the earlier stages exploring both the overall facade pattern. So here you can see there's this kind of brick pattern on one of the faces and a more regulated grid on the other. We explored both the pattern and also the development of the panel itself. So here you can see we have a few different kind of panelization options. And here we've got a more simplified panel itself. And then one of the challenges of the project was, as we moved through this project, we started to explore both these things, like the overall facade pattern and the overall panel itself, which represented the challenge of how we A, explore this quickly in Rhino, and B, how we also simultaneously have it or document it in Revit without having to expend a significant amount of time remodeling and manually modeling these elements. So here you can see the development of the facade has kind of moved on. We're now in a much more detailed exploration of the panel itself. At the same time, we're also exploring a totally different overall facade pattern. So here you can see we've got slightly more of a gridded, but it's also dissipating or kind of moving as it steps down towards the ground. And so this was the real challenge of the project. How do we, A, create some kind of workflow on the design side that enables the team to quickly explore different options in both the overall facade pattern and the development of the panel itself. And then how do we bring that into Revit without having to spend a significant amount of time manually modeling it, whilst also being able to add detail and explore the detailing of the facade itself in a bit more depth, which would then go back into, the development of the design. And so, Rhino Inside was one of those tools that stood out to us as maybe a part of the solution to this problem to navigate moving back and forth between our design space in Rhino and our documentation space in Revit. And so essentially what we did was developed a process that allowed us to kind of move back and forth. And I'm going to talk you through that process of what we actually did in the project as a backdrop to what we'll be doing in the class, which will be a much more simplified version of this. But hopefully it gives you the foundations of how to maybe tackle this in your own projects, and you should be able to add more complexity to the project itself as you go. And so the kind of starting point or the base point for our projects was the overall massing. So the team spent some time, and once they were happy with the overall massing, which was driven by, a variety of different things from zoning regulations to the design itself, they would output some kind of massing model, which you can see here. So the massing model was essentially the input for our process. So we take that massing model, and then what we did was we could do it either through manually controlled grids or computationally generated patterns or grid subdivisions of the surfaces. We could create some kind of panelization options. And so here we could kind of explore a variety of different patterns and output from that some kind of wireframe surface model. So in this case, you can see the patterns being used to subdivide the surface, and then we're outputting the surface itself, which has also been identified as different kind of panel types. So we might have a balcony corner panel versus a typical corner panel versus overhang panels and typical panels. And so this kind of represented what we called as the base script for our project. And then from that script, we would then create certain outputs from that base script. So the first thing we wanted to output is how do we translate that surface model or that wireframe model into some kind of design model where we could explore different options. And the way we did that was through a series of blocks, where the blocks basically acted as a container model for various different options to explore different design options for the panel itself. So within the block, we had like a vertical panel, a horizontal panel, and a glass panel. And inside the blocks, we have different kind of layer names, so we can turn off different kind of options and also add different design directions into them. And so you take those blocks and then we could bake them onto the kind of orientated to the surfaces and very quickly explore different design options. So you can see here, we actually get a pretty detailed model where we can really quickly explore what the details of the panel itself and also a sense of the overall facade pattern. The second output that we wanted to create was some kind of output for Revit, which would act as an input to actually generate the facade without someone having to kind of manually place all these, walls and curtain panels. And so in that case, we took the surface model and we extracted the information we needed from it, from the script, and baked out the geometry, which in this case was just a simple curve, and baked into it all the information that we needed to create that panel on the Revit side. We could save this out into the geometry itself, and we could also save it out as an Excel spreadsheet just to kind of, double check, or if we wanted to, we could use it in another process, such as Dynamo, for example. And so here we're actually saving the geometry for the panel itself, and then we can directly input that into the Revit side to generate those elements. So the design model itself, the block model, would be an input. So these kind of outputs would then be an input for our documentation process. The design model would be a kind of indirect input into how we create the actual panel itself in Revit. And so you can see the mega panel that we were working with, we could simplify it down into 3 core elements. We've got the window panel itself, we've got some kind of vertical solid panel, and a horizontal solid panel. And so that's what we're going to work with today. We're going to simplify our facade into the mega panel into those 3 elements. But from that model, we can actually create the panel from scratch, the curtain panel from scratch in Revit, utilizing the power of families in Revit. So we're not bringing in those blocks as like some kind of dead geometry. We want to create an actual Revit facade where we can control all these different parameters and really utilize what Revit is great for, which is the parametric families. And so these can be quite complicated, but essentially that design model dictates the design of the panel in Revit. And that's the only thing that we're really manually creating. And then that panel can be kind of broken down into many, many different panel types, all coming from one single panel family. And then, of course, our Revit output becomes a direct input for generation script through Rhino Inside into Revit. And so here we literally open up the model, reference that geometry that we baked out, and start to place all these curtain panels on walls and give them the correct information, different panel types, levels, and all that kind of stuff, in order to create what this is the output of our model. So no one is having to spend the time manually placing all these kind of walls and curtain panels itself. So this is the process that we set up, and also have to give a shout out to Brian Hardin for his awesome work developing and managing the Revit side of this, the panels and all that kind of stuff. And also Fabian Lorenz, who really pioneered that base script and developing the Rhino and design model kind of outputs. And so this was the process that we set up, enable for us to kind of transition from our design space to Revit, and in some cases back, based on the kind of, intelligence that we learned as we developed the panel itself, which enabled us to kind of enable the team to spend a lot more time exploring the design and developing the panel at the same time, and less time spent having to remodel things constantly in 2 separate platforms. And so this is the process that we're going to look at today. We're going to start with creating that base model output. We're going to look at this in a much more simplified version. We're going to create a base script in Rhino and Grasshopper, and then develop our 2 outputs, one for Revit and one for our design model. And then we're going to go into our Revit, develop the panel itself first, and then develop the scripts to generate and also update the information in the panel. And so we're going to be looking at a simplified version of this, but hopefully this gives you the background as to the project itself. And also the course itself will give you the foundations to enable you to apply some of these methodologies to your own projects, so you can hopefully streamline that process from Rhino into Revit. So let's jump across to the next class where we'll start this process and we'll start to create the beginnings of our process in creating that base script and the base masking geometry. So hop over and we'll see you in the first class of our course.